Okay, so let's see what we're gonna do. We're gonna start these series, and then we're gonna try to do this right here. It's been a long time since I've done anything like this. So what we're gonna do, now we start. We're gonna go over programming basics, C++. We might do some Windows API and call convention, some of it. That's what we're gonna start with. I think it even actually talks about it. You go over here, right? They start with this, and then on 12, this is 12, yeah. We actually start doing things with C++, like learn C++ and all that stuff. So let's start with these 11 steps. I'm gonna need us all kept. I don't know why they use 1.2. Why not? Honestly, it's better to do the latest, learn better. But I guess these tutorials are based out that so if you run into problems, they just don't want to ask you too many questions. So we'll start with that. And we're going to try to do as basic as possible tutorial. Let's see if we can do it. So the idea with the series is what we're going to do is we're going to try to teach not only programming, right, C++ and C Sharp. This will allow you to learn Windows, how to make programs Windows, how to manage memory. We will do assembly, probably, right? x86, either Intel or ARM based. I have an AMD here, so it might be a little bit different depending on how it goes out. But the assembly language itself is the same for the most part all throughout, or at least the architecture of it. And then we're gonna go into how all of this is made. So first things first, C++, C Sharp. We'll learn that. Second, we will do this section so that you guys can understand, together we'll learn together how all of this works. And I will show you everything that you will need to know in terms of functions, in terms of calls. Like basically, somebody who has done little to no programming will be able to not only program things that are meant for the Windows platform, programs that are meant for the Windows platform, and how to actually modify and inject things. So I would say this is probably the best resources to learn real life coding. I'm not saying that maybe Windows or like Mac coding or app coding is not real coding. It's more very specialized coding, right? So you're making specifically websites with HTML, CSS. For Android development, you're specifically doing that. Like you're still learning coding, but it's very specialized coding. This C++, this is very rudimentary coding. This is baseline coding, so such as memory, and it can be applied to almost anything. Right? You can make anything in C++. Horribly, but you can make it. While the other codings are more, I would say, specific to what you want to create, and there are a lot better tools for that. Okay, so in this video, I guess what we can start is what you will need. Now, everybody has their own little thing that they would like to use. You can use something like this, Visual Studio Enterprise. It's very expensive. You can also use the community one, which I think is free, if I'm not mistaken. It used to be paid. Free ID, yeah, so you can use Visual Studio. The difference between the community and the enterprises, there is a lot less tools for testing. So things like performance testing and intelligence, all that stuff, there's less of it. Now, do you need it? No. The beginning, you don't need it. You can yourself see how quickly things are going. You can actually use even free tools. You don't need to use specific. It's just that it's so perfect in one little environment that it's easier for you to use the professional, the enterprise. But you have to pay for that. So that's not for the average person who's trying to just get into it. It's for more professional. Like it literally is for more professional people who actually work with a lot of these things and need these tools. For a game, we probably not going to do that initially, right? Free Visual Studio. Another one that you can use, which is really good, is Visual Studio Code. So it looks something like this, right? Mine's a little bit from other things I was doing. So let me move that over here. It'll be easier to tell. Hold on. I'll give you a little bit better. So we'll just right. And what you would do? Oh, I think I know that why, because it does save. It saves profile. So you'll see something like this when you download Visual Studio. It'd be easier to just do it like this. Put it like so. This is Visual Studio Code. Now the good thing about Visual Studio Code, it is all free. It's a lot easier to install extensions like GitHub Copilot and IntelliSense, Docker, anything that you'll be working with. On Visual Studio Community or Visual Studio regular one, it's not harder, but let's just say it's a little bit more like a professional environment. It's things like other engineers will call this like SolidWorks or Altium for electrical engineers. It's a little bit less intuitive. This is very simple. You got yourself a Explorer. You got a search function which you can do. So let's say you have here's a game that I play, and let's say we just do this, right? You'll open up where it is, right? You can see all the scripts, right? You can quickly like open it up, right? You can do something like this. You double click and it will actually stay, right? So it's a lot easier to see, and the extensions are a lot easier to work with. Source control, you could do your own source control with GitHub. I think you could do Perforce as well. Let's see if it actually does that. Perforce. Yeah, so you can. Perforce for visuals. So there is some restrictions for it. Non-disclosure of this open selection. Force creation with this. Yeah, you probably have to actually download Perforce. Perforce is essentially the same thing as GitHub. In my opinion, it's a little bit easier to use because actually as a GUI, you're not doing something like this, right? So this is Git, right? In a way, so it'd be like Git status or something like that. Right, well, you have to get a actual repository. So actually, what's a good example I can show you? Let's see. Git status. So something like this, right? This would be like a Git repo. You can use CMD actually. You don't have to use Git Bash itself, right? So it tells you what branch you are. So branch, think of it like what version you're on, right? And then you commit by making it's basically, let's say you have a lot of code changes, you have a lot of things that are changing, you want to keep old versions and you want to see compare, and right, it's so that a lot of people can work on it, or sometimes one person wants to work on it. So let's say do git status, for example. That's a basic command. They'll tell you, right, hey, you're on branch master, so right, like your branch is this. So like let's say what version you're on, master being like here's the main master version, right? And branches, think of it like, let's say you want to add your own feature, but you don't want to add it to master yet. You want it to be like a separate thing that you do testing on, and then it's like when you're ready, then we will push this feature to the main program or something like that. It's like it's going to be like a beta version of a program, or it's going to be like a second version of this program for a specific customer or specific, it's basically, hey, I want a different version and I don't want to mess with the main. So you create a branch. You can even, I think you can get branch A for all, right? And it will show you all the branches you have. So remote means this branch is not locally. So this is like on GitHub itself, right? The ones that are not remote, they'll be local branches. And the way you basically, so what you do is you create a branch locally and then you push that branch to remote, to GitHub or to Perforce, right? Like Perforce is similar in that sense, but in specific for Git is a little bit different. Origin means like, okay, what's the original, right? Sometimes they call this differently. Sometimes they actually might call it master instead of origin. It depends on the convention, but usually origin is the actual way they do it. Head is basically trying to tell you, okay, where are you? Like, what's the head? Where are you? Which branch you're on? And it'll tell you, okay, you're on origin master, which is right here, right? If you want, you can do VV, which is verbose, I think, verbose variable, something like that, and I'll actually tell you which git commit. And commit means like, okay, let's say my first commit is first program, and then my second commit will be update uh, update one. So that would have a second commit. It'll be a different, it'll be like something like this. And this is the shorthand form of a commit. Usually the commit is actually like a long number. I forgot exactly how many numbers it is. But this usually you can tell by which commit it is by just the first, I think this is what, eight letters or 8 characters. And that's enough to distinguish most of like the commits that you ever made to your. Anyways, this is a completely different topic. We'll talk about this later. We'll go over it. So, what we will do first this thing. First steps of guidedhacking.com. First 12 steps, right? Because the 12 steps. Step 12 would be to learn C++, right? Oh, it's overwriting it. Okay. Learn C++, right? And then, as we're learning, we will learn Git, or basics of Git basics. After Git basics, we will start doing things with actual APIs. So that will be Windows APIs, Windows calls, GUIs, so how to create a graphical interface. So, for example, this is a graphical interface. Your website technically is a graph. This is a graphical interface, right? All of this is a graphical. This is actually a console. So for everybody who's not actually tech savvy, this is a console or a command prompt, if you want to say CMD, right? And your computer, right, or your user computer, right? Because when you go to your Windows, most things run roughly like this. You just don't see this. It doesn't pop up. It's in the background. But these commands, right, like git branch, git this, git that, a lot of it actually does happen in the background, right? Or internally, right? Like, for example, something like this, right? Even though this is a coder, right? You have a program that executes code to create code, right? So it's a little bit of a loop. But in a way, right, when I click this button and this button, a function is getting called for me to come here. So come here. And then when I type and then I enter, another function does something. Me moving this, in a way, is a function. And that function is done by Windows. And it's kind of an interface between this program and between Windows. So in terms of the basics, everything you see on screen is in a way kind of like git branch VV, right? It's like something is getting called in the console. Now, the more proper, like tech savvy people tell me that no, not everything's running on a console. Like there's not always like a function running. I agree. Yes. So sometimes it's like an internal kind of DLL file, a library file, and it's making calls to the library there. And it's not a command. It's itself like a capsule, like its own little box, if you want to think about it. And then it's grabbing things out of the box, putting things back in the box, right? Like whatever. Well, it usually doesn't put back in the box. It's more like creates copies of a box, but I'm going off a tangent. But all I want you to know is that programs, for the most part, are just a bunch of functions that somebody coded. And by clicking it, that click or that command is asking the Windows. Windows goes in here, tells the program, or this program tells Windows, hey, I want to run this function. It grabs it from a file, a DLL, or whatever it's storing that function is, grabs it, brings it back, does whatever it needs to do, or it asks Windows to do it itself, right? So Windows itself has the same thing as little DLLs and functions that other programs can use. They're called APIs. Sometimes they're functions in itself. And you can find these functions a lot of times in System 32. Yeah, I think it's. I mean, honestly, you can find it all over the place, but I already forgot where. Where is it even? Oh, well, I've been not checking this in such a long time. System 32. Hey, maybe it's actually not. Yeah, it's a bit different now. I already forgot. Anyways, the whole point is that somebody created functions, somebody created files. They stored this in DLL files or some kind of packages, and then you or programs or in between programs or Windows tells the programs or the program, right? They all share the code, they all call each other, and they all integrate within each other. Think of it like functions that are going to be running other functions, doing other functions, and so on. That is the basic sense of how programming works. Now, the under the hood, it's just memories, jumps, copies, deletes, splits. That's how assembly works. It's just you're moving one memory from one register to the next. Or I guess you're in registers. Think of it like locations that store specific memories, and based on the type of system you have, 32-bit, 64-bit, it does things a little bit differently. Anyways, we're going a little bit on the tangent. Let's get back to what we're gonna do. So let's do the first 12, right? We'll practice in a cell cube, and then we'll do things actually, right? Like we'll first practice on the cell cube, right? We'll learn C++. We'll do some Git basics, API, GUI, so that we know what we're even doing, right? Like we know what we're doing at that stage, and then we're gonna go in and let's do. Let's see what a good game is to check. Oh, I was confused. A good, easy game to that everybody's gonna enjoy. It has to be a simple one. I don't want to do any online. This is gonna be a little bit tricky because of the cameras, but I don't want to do that yet. I mean, we can do CS:GO right away, but let's see. All right, whatever. We'll figure it out. We'll figure it out later which one we're gonna do. Okay. Let's hope the series goes somewhere. And thank you, everybody. Hope to see you in the next episode when we're actually gonna go and tackle the first 12.